Hello, I'm Derek. I'm a software engineer here at Syntasso, and today I'm going to be presenting from zero to paved path in 15 minutes. Build your platform API fast. Before we jump into the hands-on demo, let's just go through a little bit of history on what are some of the problems that we see with platform engineering as it's done today in a lot of organizations. So as you all remember, the beginning of times, there was dev and ops, had separation there. Some people build, some people run. They did not talk to each other. All sorts of problems raised from that. The world got better. We had DevOps. DevOps, we had members of the team. They were part of the same team. People that run, people that know how to run, how to deploy, and people that build their apps. They were part of the same team. But there's a lot of shared concerns and a lot of time that's like different teams were spending doing similar set of stuff. And that's how the platform engineer came to existence or became a thing as a team that looks at across all those teams and tries to centralize and try to deal with some of those concerns, of those shared concerns through an internal platform. And how are internal platforms done these days? They're usually, we've been observing, it's one of those particular types. So we have a ticketing systems, we have access to a Kubernetes cluster, we have access to a cloud account, and we have Terraform, templates, blueprints, those kind of stuff. And they're all good for some reasons, and they're all bad for some reasons. So with ticketing systems, you have a customized for the organization. Someone sends a request, you wait for it to happen, and it will be exactly as you asked. But the downside of it is they're slow, oftentimes involve manual processes, which are prone to error. And it's just not the best experience. The Kate's access to a Kubernetes cluster, it's good, it's clean and consistent API via Kubernetes itself. But then each one of your application developer teams are in fact a platform team. They are dealing with the platform concerns. Or you have access to a cloud account. And it's good, you have on-demand, you have self-service, you can create services as you need, but it's not customized to your organization. You also have, on the other type of platform, you have blueprints, which is like a bunch of Terraform that have access, or Helm templates, or all those sort of stuff. And they're good, they're high level, they're customized, but who writes it? Who runs it? There's all sort of those concerns. So what if we could get all of the benefits, all of the plus sides of all of those types of platforms and unite them to a single customized on-demand platform API? And that's exactly why Cradix exists. Cradix tries to provide platform teams a way to build that on-demand customized platform API. And through that, promising full developer experiences. So let's imagine a certain scenario. You have an application team. They need some way to serve their apps. They need some data, access to like some data store. They need to do some caching. You talk to them. You realize that they're using Nginx for serving their apps, Postgres for the data, Redis for the cache. You go ahead and you wrap that into a promise. Promise is the Cradix component that allows those particular services to be consumed on demand. But you go one step ahead. You're like, cool. What if I provide more than that? I provide an entire environment. So my application developer team comes, requests an environment, and that's what they get. They get an instance of each one of those things. Maybe you have a differentiation. You like, they can get a dev environment, a prod environment, and they may be the same. They may be slightly different. There's like PCI compliance, all sort of things that can happen. And then you can continue building on that. You can compound promises and build more complex promises. Like you can have an observability promise that delivers dashboards and monitoring with Prometheus and Grafana, or a CI/CD promise, and etc. But those are just a bundle of tools. How do you provide experiences? You provide experiences by thinking about what it is that your app developer team needs to do and providing that as a promise. So for example, all I care about is to run my app. I give my app to the platform. It runs it for me. I get my DB, I get my caching, I get my Grafana dashboards wired up to that app. That's a full developer experience. There is more that you need to do. You also need to care about security, compliance, governance, all of those business concerns. So you just throw that in here. And in Cradix, you can do that through the pipeline that we're going to look when we jump into the code a little bit later on. Yeah, and that's exactly what we're going to do. We're going to build this developer experience that goes through writing this promise that will not provide all of this because there's a lot of things in here, but just to give it as a start, we're going to do compliance and governance through Slack. We're just going to send a notification on Slack, and we're going to combine Nginx, Postgres, and Redis to provide this app as a service experience. So let's jump into the demo. Cool. So let's build this platform. To start us off, I created a couple of Kubernetes clusters with kind, platform and a worker cluster, and I also installed Kradex in the platform cluster. So Kradex should be up and running over there. And I also registered with Kradex a couple of clusters, the platform itself and that daughter cluster, the worker cluster, to tell Kradex, these are the available clusters that you can run your workloads on. We're not going to go into much details about registering clusters and what that means, but it's all available in kradex.io. You can read about that in the documentation. Okay, so as we discussed, we'll be building a app as a service promise. This promise will be a combination of other promises available in the marketplace, kradex.io/marketplace. And the goal is to provide a better experience for the app developers. So instead of saying you can get Postgres as a service, you can get Redis as a service, we're going to combine all of those into a single experience. And the user can say, run my app, I need these databases, and they are good to go. So beforehand, I prepared here a directory containing a few files that we need. We have the pipeline directory that contains the pipeline definition, the pipeline files. We look at them later. We have the promise template, which we'll be using to build the promise. So we're going to look at that next. And you also have the worker cluster resources, the WCR directory, which contains the promises that I downloaded from the marketplace. We'll later run a script that will inject those into the right places into the promise. And we're going to be installing that promise. So let's go ahead and build a promise. So let's open the promise template file. It's a Kubernetes definition of a promise. You can see the name. So this is the name that will be available for the users when they list the promises that are available in the platform. The first field we have under spec is cluster selectors. You can see that it has a value of environment platform. And this is telling Kradex that the dependencies of this promise should be installed in a cluster, in a registered cluster that has those labels. And in this case, that will be the platform cluster itself. And those dependencies are defined in the worker cluster resources. In our case, this will be the Postgres, the Redis, the Slack, the Nginx, all of those promises that we mentioned. And as I said, we run the script that will inject those values here. So don't worry that it's empty right now. Next, we have the access service CRD, which is a custom resource definition that provides that will contain the API of your promise. We include here the fields we want our users to configure when they request a new instance of the service that we are promising. So let's go ahead and do that now. Just defined here under the API v3 schema, we have a spec, and we're saying that our users will be able to configure the following fields: DB driver, image, and name. DB driver, we are making it enum, so those are the available values that people can set. And you can say Postgres or none. And what we're doing here is allowing ourselves in the future to add more support. We only support one particular database right now, but we may learn from our users that they need different types of databases. So we don't want to break their APIs. We want to make the resource request to be consistent. So later on, they can just add a new value here, and that's going to be the API is already set for the user. We already have the image, which is what is the container image that we want to run for this application. And we also have what is the name, like a vanity name that you give to this application. So when we list the deployed applications, that's the name we're going to see. And finally, we have the request pipeline, the access as a service request pipeline. And this is a list of containers that will be executed in sequence. Our pipeline will receive the request and transform that request into smaller requests for each one of the individual underlying services that will make up this experience. So let's write that pipeline. So the pipeline is a container. And in our case here, we're just going to use bash. but you could use any language that you want. And what this pipeline will be doing is it's going to extract from the user's request the configuration and make decisions based on those configurations. So for example, here it will say, is the DB driver Postgres? If it is, then we have like a base manifest for what a Postgres request is. Let's update that with the fields or the values that the user is passing through, and let's save that into the output. By the end of the pipeline, anything like after all the containers image have run, Cradex will look at the output directory of the last container and just schedule everything that is in there to be run on the worker cluster or in the platform cluster, depending on where those should run. And you can see that even at this promise is like a lot of other promises, it sends like several resource requests. But that's it. It's quite simple. It's the pipeline is where you can also add like off gates orchestration. You can run Terraform. You can call APIs. You can do pretty much whatever you want. Cool. So let's save that in quit. We're not going to be able to use that right now because we need to first build the image. So let's do that. And we also need to load that image into the kind cluster. We could potentially push that to a registry, but for simplicity, we're just going to load this into the cluster. Cool. So now that's done. We can use that script that we inject the dependencies into the promise file. So we have like a complete promise that we can now install. So let's install it. That is done. So that's now available in the platform. And your job here as the platform team is done. You build a promise, you talk to your users, you build a promise, you encapsulated that experience, and you can now just let them know that this new service is available on the platform. So now we're going to switch hats and write what the application developer needs to write in order to get a new app running. So at this stage, we should be able to observe two things. The first is a new CRD appears in our platform cluster. So we should be able to see that we have the apps CRD here now defined, which tells our users you can now request things of type apps. So you should also be able to see on the worker cluster that the dependencies for my promise are now up and running. So our promise depends on the Postgres promise. The Postgres promise depends on the Postgres operator. The Postgres operator got deployed to the worker cluster and is now waiting for the request to come in. So let's write that resource request. So the resource request is, again, what the application developer would write. And it contains pretty much the simplification of the fields that we define in our access as a service CRD. So the application developer comes here, defines the name, defines the image, defines the DB driver. And when we apply that, they should get their apps running with a Postgres database on the worker cluster. So let's save that and apply. Apply the resource request. That has been accepted by the platform. So at this stage, we should be able to see the pipelines kick it in. So this is an interesting thing with compound promises. The pipeline for the app as a service promise will kick off the pipeline for the other promises that is made of. So you should be able to see as soon as it completes, new pipelines coming up. So you should see now the Postgres pipeline coming up, the Redis pipeline coming up, the Slack pipeline coming up, and so on and so on. And eventually they're all going to complete, and we're going to have the full system, the full output of those systems scheduled to the worker cluster. So let's just wait for that to happen. Looks like we are good to go. So at this stage, if I look at what's going on in my worker cluster, I should be able to see a few things. First is the Postgres database is starting. We can see there that there is a ACID to do Postgres 0 that is being created. We should also see the app is trying to start. The app is going to fail at this stage because Postgres is not running yet. So it's just going to be at that state of like pending for a little bit until Postgres coming up, and then it will successfully run. So let's just wait for that to happen. And here you go. With the magic of editing, we now have everything up and running. You can see that the Postgres is up and running. You can see that the app is satisfied. So we should be able to go to our browser and see the app live. All right. And with that, we have our platform. But what else can Kradex do? Kradex offers, as you could see, multi-cluster scheduling capabilities. You can decide in which cluster your workload should run and where should it go. We have the marketplace of promises, where you can browse an array of available promises and pick and choose what you want. And you can, of course, always build your own. You can also have user interfaces that are deployed in front of Kradex, like Backstage or Compass, and have your users to send the resource request through those UIs. And as you can see, it's also composable. You can use multiple promises to build more, bigger and better developer experiences. If you want to learn more, I would invite you all to try our docs at kradex.io. We have a lot of documentation. We have a few guides, a couple of workshops. It will be awesome if you could try and give us some feedback. And also, you're also all invited to contribute and take a look at the code. It's available at GitHub. It's open source. So yeah, thanks very much for watching.